Okay, let's do chapter 8, and chapter 8 is about confidence interval. Up to now, we were talking about the point estimators for the population parameters. But we only have point estimators. We estimate mu based on x bar, we estimate p based on p bar, right? And that's it. We say that x bar, the point estimator for the mu, is equal to x bar. Now we are going to establish intervals, and we are going to say with some degree of certainty that the real population parameter is between those, in that particular interval between those two values. That is the purpose of interval estimation. Try to locate with a particular level of certainty the real location of the population parameter. Okay, so first of all, we have to establish a confidence level. How sure we want to be about what we are saying. And the confidence level usually is 95%, but it may change. I may change to 90% or 99%, depend on the particular circumstances of what we want to address or assess or infer about the population parameter. Okay, this is a very, very easy chapter. We may have either the confidence level for the population mean or the confidence level for the population proportion. How are we going to do that? We are going to use what? The statistics. What is the statistic for the mean? X bar or the sample mean. So from a sample, I'm going to try to infer where is the real location of the parameter of the population. Now, after we establish the confidence level, we are going to establish the significant level, that is 1 minus this one. So, for example, if I have a confidence level of 0.95, my significant level is 0.05. If I have a confidence level of 0.99, my significant level is 0.01. Okay? And this significant level is what is called alpha. And alpha is a very important element in establishing confidence interval. Okay, anyways, this is just a summary of the chapter. We have two possible population parameters where we would like to find interval, confidence interval for where these are located. For the population mean, we have two possible alternatives. When we do know the standard deviation of the population, when we know the standard deviation of the population, we are going to follow this path. When the standard deviation of the population is unknown, we are going to use this formula. Okay, when we know the standard deviation of the population, we are going to use this formula. Remember, we are trying to establish an interval, and that interval is based on what? On the sample, and for the mean is x bar. And the interval is x bar plus or minus what? Z of alpha divided by 2 times sigma over square root of n. This is my confidence interval for the population mean. And I'm going to do a few problems later on. When we do not know the standard deviation of the population, then we are going to use another probability distribution, that is the t distribution, but we are going to use the same x bar plus or minus. Instead of z, we're going to use the t distribution. And later, don't worry about that. with n minus 1 degrees of freedom and alpha divided by 2. And since we do not have the standard deviation of the population, then we need to use what? Because we don't know it. We need to use the standard deviation of the sample divided by the square of the mean. Okay? And this is the confidence interval when sigma is unknown. The confidence interval for the population mean. What about the confidence interval for the proportion? Again, we're going to use, instead of x bar or whatever, we're going to use p bar, because we're going to infer something based on the sample. And the confidence level over here is p bar plus or minus z of alpha divided by 2 times what? P times 1 minus p divided by n. That's it. This is the confidence interval for the population proportion. And that's it. That's all the chapter is about. We are dealing with confidence levels. Confidence level for either the mean or the proportion for the population mean or population proportion. And we are going to base that decision either in the sample. For the mean, we're going to use x bar. But for the mean, we have two alternatives. Either we know the standard deviation of the population, or we do not know the standard deviation of the population. If we know it, we use it. If we don't know it, then we have to use not the standard deviation of the population, but the standard deviation of the sample. Because we do have the standard deviation of the sample. We do it. We have it. And instead of using C, we're going to use T, that is also a bell-shaped kind of distribution with n minus 1 degrees of freedom, and the same formula but using S. For the population proportion, we're going to use P bar, that is the population proportion, the sample proportion, plus or minus the Z times P1 minus P divided by N. P what? P bar, guys. Sorry about that. Okay? Because that's what we have. Divided by N, and N again is the sample size. That's it. That's easy.